We now begin our discussion of random number generation, and we have a simple first example in which we're going to produce 20 random values in the range from 1 through 6. And we have just a small example to demonstrate this concept. Let me go ahead and run it for you. Now you'll notice, I'm actually going to run it twice here just so I can show you a couple of things. So you'll notice I have two different output windows here, and first of all you'll notice the set of values that was produced each time is different. In C#, when you're playing with random numbers, by default it randomizes the pseudo random number generator, but you can seed the random number generator if you need to produce the exact same sequence of pseudo random numbers for testing purposes. So the default is to be randomized, but you do also have the ability to use a fixed seed for testing purposes if you need to. So as you can see here, we're producing only values from 1 through 6 in both cases, and now we'll take a look at how we did that. So once again, we have a simple class that just contains main, and within main, one of the key things we've done is here at line 9, where we're creating an object of the random class. And the random class, if I hover over it, you can see is in the system namespace, which is included with the using statement at line 3. So we're creating a random object called random numbers, and we're assigning it a new random object. Now you'll notice as I hover over the constructor name random, it indicates that there's also another overload of that constructor. And basically the overload of the constructor is a version that allows you to supply as an argument the seed for the random number generator. And if you do supply a seed, what that's going to do is use the seed as part of the pseudo-random number calculation, and therefore every time I run the program it will start with the calculation based on that seed and will thus produce the same sequence of pseudo-random numbers. So if you need that repeatability, you do have that available to you. Next, we declared the variable called face, where we'll store a value produced by our random number generator. And we're going to loop 20 times with the integer counter going from 1 through 20 and execute line 16. Now the random class has lots of different capabilities for generating random numbers. The particular function we're using here, or method that we're using here, is the next method, which is going to return an int value. If I hover over it, you can see that it returns an int, and it takes two arguments that it calls min value and max value. And it produces a value from min value up to but not including max value. So you can see here we're starting at 1 and we're going to produce numbers up to but not including 7, which gives us numbers in the range 1 through 6, which just happen to be the values on the faces of a 6-sided die, which is what we'll be using in the next couple of examples. So we produce one random number with this next call, and at line 18 we display the value of that followed by several spaces. And if we've displayed 5 values, we also move to the next line with a simple console.writeLine call. Now let's take a look at class random in the online documentation for a moment. So I'm going to click in the random class and press the F1 key, which will take me directly to the documentation for class random. And again, you can see that the class has constructors and methods. And if I click on the constructor, it shows me the two different versions of the constructor. One that initializes the class with some default seed that's based on the time, which is constantly changing, and one that receives an int32, which is an integer value that can be used to seed the random number generator with a specific value. If I go back to the class, we can also take a look at its methods. And you can see that there are a number of different methods here. The ones that produce random number values are the next methods. So you have next with no argument, which just gives you a non-negative random number. Next with an integer argument, which gives you a non-negative number up to but not including that value. And then the version that we used, which specified a range with a starting value up to but not including the ending value specified in the second argument. You can also fill an array of bytes with random byte values, and you can produce random double values in the range 0.0 through 1.0. So you've got lots of different capabilities. By the way, take a look at the icons in the left-hand column here. If I hover over one of these, you can see that it represents a public method of the class, but you also see some methods with this little key icon on them. Those are so-called protected methods. And when we get to the Classes a Deeper Look lesson, we'll start discussing public, private, and protected, and the differences between those member access specifiers. Protected is an intermediate level of access in between public, which is something that's accessible to everybody, and private, which is something that's accessible only to the class in which it's declared.